Governance is a set of controls or guardrails that you put in place to ensure AI systems remain safe and ethical. On the other hand, responsible AI is a set of practices for building AI systems to fairly impact customers and society. By implementing AI governance, organizations can build AI systems that are not only effective and efficient, but also ethical, fair, and responsible. In this talk, I'll be focusing on generative AI governance controls, share a reference architecture for implementing those controls, and demonstrate an example implementation. My name is Ram Vittal. I'm a principal generative AI specialist focusing on governance and security for building responsible and scalable AI systems. You can think of governance as a set of controls that you implement across your AI system stack to ensure it is secure, scalable, and responsible. There are two types of controls you can implement. Preventive control, prevent an action from happening, example, unauthorized data access. Detective control, detect an action after it has occurred, example, compliance monitoring. An AI system needs to implement these controls across multiple layers: infrastructure and security layer, data governance layer, AI/ML tools layer, generative AI application layer. Generative AI applications, such as financial advisor chatbot, needs all of these layers of controls to function as a responsible AI system. Let's dive into each of these layers. For infrastructure and security layer, you can leverage AWS organization to organize your AWS accounts and apply preventive controls, such as service control policies and detective controls such as AWS config rules. With Security Hub, you can improve your security and compliance posture by implementing controls based on industry best practices. For data governance layer, you can use Amazon Data Zone to catalog, discover, share, and govern data based on your AI project context. With AWS Lake Formation, you can scale your permissions centrally, govern access, and build your own data hubs for data governance. With Amazon S3 Access Grants, you can provide token-based access control to your S3 objects. With KMS or Key Management System, you can encrypt your data at rest and protect your data. With Amazon Macie, you can discover, classify, and protect your sensitive data. For AI/ML governance layer, you can use Amazon SageMaker Model Card to document critical details about your machine learning models, such as intended use and risk rating of a model, training details and metrics, evaluation results, and observations to help with your model governance. SageMaker Model Registry helps with governance by providing a centralized repository for managing machine learning models, enabling organizations to track and control model versions, approvals, and deployments. SageMaker Clarify can help you understand why your machine learning model made a specific prediction and whether bias impacts this prediction during training or inference. You can also leverage AI observability tools from our partners like YLabs and TruEra to implement controls on your models. For generative AI application layer, you need to implement controls to detect hallucinations, sensitive data leakage, toxicity in your large language model or LLM responses. You also need to implement controls to prevent prompt injection and ensure your responses are relevant and accurate. Next, we will look at a reference architecture for implementing these controls. This is a multi-account reference architecture for implementing generative AI platform governance. Let's start with infrastructure and security layer. Here, you leverage Control Tower Service to build out a well-architected landing zone. AWS Control Tower is a service that helps with governance by providing a central location to set up and manage the governance of AWS accounts with over 350 plus built-in controls, allowing for scalable, secure, and compliant multi-account environments. It centralizes all your CloudTrail logs into Log Archive account. It helps with setting up central networking with Transit Gateway to interconnect your accounts. And it supports custom blueprints and that you can set up in shared services account to vend new accounts with resources that complies with your organization controls. Control Tower also helps with setting up security services such as Macy and Security Hub at the organization level. Next layer is data governance. Here we set up data lake accounts with Amazon S3 for raw and curated data, and open search clusters for storing document embeddings for vector similarity search for your retrieval augmented generated or RAG use cases. Lake formation service is in the governance account. It provides a central data governance function such as data access controls and audits. Feature store account hosts a central SageMaker feature store to help with sharing features across use cases. Next layer is generative AI governance. Here we set up generative AI blueprints to deliver generative AI tools to GenAI teams. GenAI data scientist authenticates via Identity Center and connect to their SageMaker Studio in their development account. They build, train, evaluate, and register their models in Central Model Registry. Prompts and responses are tracked in Prompt Catalog. Model owner or ML engineer approves the model for test deployment. CI/CD process deploys the model to test account, where it is integration tested and then approved for production deployment. CI/CD process deploys the model to production account. And finally, all the logs from CloudWatch and applications are sent to central bucket in observability account and visualized with QuickSight or other tools. We discussed the architecture for setting up infrastructure and security layer, data governance layer, AML tools layer. Now let's walk through a demo and see how to set this up. In this demo, I will show how a cloud admin sets up AWS Control Tower, organization structure, and shared services. And a data admin, how would you set up a data lake, feature store, and data governance? And then ML admin, how would you set up a generative AI platform, shared services, and team environments? And how would a data scientist connect to their team environment and use SageMaker Studio to access governed data and prepare data sets for model fine-tuning? And finally, I'll show how a data scientist fine-tunes and deploys a model to model registry. We talked about 3 layers of controls, so I'm going to be demonstrating how to set that up, starting with the infrastructure and security layer. So what I'm going to start with is how to set up Control Tower, which is one of the foundational services that helps you set up multi-account environments. So let me show you how to do that. So I'm on an AWS account, and as you can see, there is a Control Tower as a service. I click on that, and I've already set up the landing zone. Landing zone is a well-architected blueprint that you can use Control Tower to set that up. And when you set it up, it provides you some baseline accounts and organization structure, and we will be extending that as we go through this demo. So let me quickly walk you through that process. So here you can see, so the way you get started is setting up the Control Tower from this Control Tower page. Once you have set it up, you will see your landing zone is now available. Like you see here, you would see 2 organizational units, 3 shared accounts, and some 20 preventative controls. So you can go and add or enable more controls. The way you do that would be go into all controls, and in this controls page, you can see there are over 500 plus controls that Control Tower provides out of the box. And you can also add your own controls, the controls we spoke about, the detective or preventive controls. As an example, I can show you for S3, Amazon S3, there are a number of controls here, right? So you can see there are a number of detective controls. An example could be detect whether public read access to Amazon S3 buckets is allowed. That's a detective control. And we also have preventive controls. So, and here you can see a preventive control, right? disallow changes to logging configuration for Amazon S3 buckets. That's a preventive control. So you can set this up, enable these controls simply by selecting these controls, and then you hit enable control. So that's controls. So when you start to build out your organization structure, so you would just go into organizations, AWS organizations, and that's where you would set up your account structure, right? And here you can see I have already set up an account structure, right? So by default, when Control Tower is created, you would have the sandbox, the security, organization units, and then the rest you would build out as you move forward. So in security, you see a couple of accounts that out of the box Control Tower creates. One is Log Archive to store all your CloudTrail logs, centralize it into one place. And security tooling is basically auditing all your security events and collecting it to a central account. And then from there, you can add more accounts as your based on your requirements. As an example here, you can see under workloads, I've created a number of accounts, right? So we'll talk through this as we go along. So we have a data governance account, we have a data lake account, feature store account, and so on. So how do you create accounts? So Control Tower provides a simple mechanism for you to create accounts. So let's get there. So with in Control Tower, I can actually go to Account Factory, and then I can hit this Create Account button, and then I can provide basic information about yourself, like what's your account email, display name, identity center user email, and so on. And then you finally select a OU that you have already set up, right? Is it going to be part of workloads or infrastructure OU, right? Select that, and then you would provide customization. So what is customization? Basically, you can actually set up a blueprint and use that blueprint and reference that blueprint when you set up new accounts. So in the blueprint, you can configure resources such as VPCs, subnets, security groups, and even other services, like if you want to deploy SageMaker Studio and so on, IAM roles. All of them can be part of the blueprint. And that way you can control and govern your accounts. So basically here you would provide the account where you have created the blueprints. I'll show you in a minute how to create that. And then you can plug that in, and then you can select the product here, and then you can go ahead and create the account. So also, when you create the Control Tower, by default it creates IAM Identity Center. You can actually configure Identity Center for your users and groups, right? You may have your identity provider, such as Okta or Ping. You can bring those users and groups from your identity provider into Identity Center. There is a skim sync function that you can use to bring it in and keep it in sync. Once you have it here, then you can easily provide access controls based on the users or groups to different accounts and applications. That's the function of Identity Center. So here you can see I have set up some users like Alice. Alice is a data scientist. So for Alice, you basically would have had Alice and other users in your identity provider system. You would just sync it here. And once you have those users and groups, you can use that users and groups to assign to applications and to AWS accounts. So the way you assign it is basically go to these AWS accounts, and then you would select the accounts that you want your users to access, and then you basically do assign users or groups. And that's how your users or groups would be assigned to that particular accounts, and then they can actually connect to those accounts right from the Identity Center portal, which would be something like this. So here they would get a list of accounts they are authorized to, and then they can navigate to that account by simply clicking on their access group. Here I have admin access. You could set it up as a data scientist or a data lake admin and so on, and that's what they would see, and then you click on that and navigate to that particular account. So now let's move on to how would you set up shared services account, which is one of the accounts we spoke about earlier. So let me talk about that. So here you can see there is infra shared services account, which is basically at the enterprise level you're setting up shared services, such as maybe you have enterprise CI/CD functions, right? So for all workloads, or you have Active Directory and other services that you want to use enterprise-wide, and that's a function of enterprise infrastructure shared services. And that's where you would set up blueprints for vending accounts. When you're vending new accounts, you want to attach a blueprint to it so that that account gets vended with well-governed infrastructure resources. So let's see how that's done, right? So I'm in infrastructure services account, and there you can see the way you create blueprints is using CloudFormation or Terraform, right? And then you can put them into a products as part of service catalog. And you would see, and then once you have those products, like here I have Bootstrap accounts portfolio as a portfolio, which has a list of products. So these are the products or blueprints that your users will see when they go and try to create an AWS account from Control Tower, which I was sharing earlier. So as an example here, they would see ML Play account or a shared services account or a restricted account. So those are some of the names we have given to build out accounts with particular set of configuration. And that's shared services. So now we have built out our infrastructure layer of controls, accounts, and resources. The next step is setting up your data governance layer, right? So for the data governance layer, we have to start with the data lake, right? So data lake, you would have a centralized data lake, could be one or more accounts depending on how you structure it. So here I have an account. So primarily you would use Amazon S3 as your data lake, and that's where you would set up your process your raw data, set up compute to curate the raw data and create curated data sets, and then use those curated data sets to build your models, right? So you would have to share that data set with your ML teams or generative AI teams, and they would use that to build out the models. And then they may create features, and those features would have to be stored in a central place so that that can be reused. So here you can see there is a data set, a couple of data sets I've created, one for a bank, another for a investment function. So those data sets can be used to train or fine-tune your models, and that's what I'm going to be showing you next. So let's see, in order for your teams to get access, you would have to enable that first, right? So right now I have the curated data sitting in my data lake as a data set. How would I get that to my data scientist? So the way you would do that would be setting up a data governance account and use lake formation, right? So we'll look at it next. So here you can see a central data governance account where you would use enable lake formation, which is a service that helps you set up central data hubs with fine-grained permissions for your data. And here you can set up, you would basically scan or set up glue crawlers to crawl your data lake assets, and then create glue tables, and then provide, share these with your consumers, right? So, and that's kind of what it is I'm showing here. You can see here the investment dolly one I was showing you earlier is actually a table, and that will be shared with your consumers. And that is part of the function of lake formation. Once that is set up, and then you can set up here the data lake permissions to share with a particular set of roles or principals. So now you have that, and then you have to enable your teams to build models and give them tools to build models, right? So, and SageMaker Studio is one of those tools your teams could use. So for them to get that environment, you would have to, as an administrator, as an ML administrator or a generative AI administrator, you would have to provide that function to them. And that's where this generative AI shared services comes into play, right? And there you would have products. You would create products such as SageMaker Studio Domain, or if you're using SageMaker projects to build and deploy your pipelines, you would set that up here. And that's what you're seeing here. And if you click on this product, you can actually launch this product. You would share this product with your ML teams or generative AI teams, and they would use that product to launch SageMaker Studio with the right set of resources. So basically here you can see they would provide a name and provide some tags, right? So who is the owner for this asset, and what's the business unit, what's the cost center, and so on. All of these would be used to tag your resources so that you can compute cost at the end of the day and allocate cost accordingly. And here you give a name to your studio domain, and then if you're deploying it in a VPC environment, the VPC environment information parameters can be provided as well. And then you finally launch the product. And that would create a SageMaker Studio domain, and that's what your ML teams or generative AI teams will use. So let's look at one of those products, how it looks like. So when I launched it earlier, it created a SageMaker Studio domain. Actually, this is the one I created earlier. You can see SageMaker Gen AI Team 1 domain. And this is what your team gets. And then when they log in, when Alice logs in, a user profile would be created. And that's what they would use to launch SageMaker Studio and then build their experiments from there. So now let's assume Alice is logged in and they want to use the data that you have shared with the team. So I'm now logged into the Generative AI Team 1 development environment, right? That's an account by itself, and that's where they have launched this SageMaker Studio product that their admins have shared with them. And here you can see I have a notebook open from SageMaker Studio. And this notebook is basically the data scientist Alice is logged into this particular notebook, and they are going to actually prepare the data set for fine-tuning a model. So they need to be able to access the data that was shared from the central data lake and data governance account. So how would they access it? So here you can see I'm doing the basic setup, setting up Bodo 3 and SageMaker session. And then in order to access that, I need a role. So basically I'm using STS, and then I'm using an Athena consumer role, and I'm doing an assume role. And then once I assume that role, I have those credentials as part of that role, and then I can use Athena, Bodo 3 Athena resource to start the query. So I'm doing a select star from investment Dolly QA, which is the data set I was showing you earlier. And I can query that data set. This data doesn't exist in my account. It sits in the data lake account, and it is shared through the data governance account that I showed you earlier through lake formation. And I'm using Athena to access it. And this role is authorized to access that particular shared data set, which is shared as a glue table. And I'm able to query that data, and you can see here as part of the query, get query results, I'm converting it to a data frame. And basically this is a instruction, context, and response. Those are the fields present in that data set. This is basically prompts that we use to fine-tune the model. And that's the data set that I'm able to share and access. And here basically I'm doing a very basic data preparation. I have the access to the data set right now through glue table via Athena, and now I'm doing a train test split and then splitting those data sets, and we'll be using that in the next stage of fine-tuning the model. So now I have the data set, I can fine-tune the model. So let's get to that. So basically I'm going to fine-tune the model. I'm in a new notebook for fine-tuning the model. Basically I'm going to be using that Dolly data set for fine-tuning a model for investment advice. Right, so this is fine-tuning Llama 2 models using the SageMaker Jumpstart Llama 2 model. I'm doing some basic setup, setting up the model inversion, and then I am setting up the data sets, and then I'm using the Jumpstart to instantiate the estimator and starting the training job, as you can see here, estimator.fit using the training data location. And the training is already done here. I've done that earlier. So the training is completed and is uploaded the generated model. And now I'm going to deploy the fine-tuned model and then run inference on it. Right. So I'm attaching my training job and then calling the deploy function. And that is deployed to a hosting endpoint. And now I'm able to predict with that fine-tuned model, right? So I can send my payload, basically my input, in this case the prompt. So I'm just asking a question, simple question: what are the benefits of Roth IRA? Since this is a financial advising bot, I'm sending in the basic parameters that the LLM needs, such as max tokens, top P, temperature, and so on. And then I'm calling the predict function. And it comes back with the response, what is a Roth IRA, what are the benefits of it, right? So, and then once I'm done, I guess you could ask multiple questions. The intent is to showcase how you can access the data and fine-tune a model, right? So, and then once you're done, you want to be able to register the model, and then from a governance perspective, you want to version it, register the model, attach your training job as well for tracking how this model was created, and hand it off to your deployment or ML engineers who can take it forward to their test and production. So basically, in order to do that, you would create a model package group and register the model, and that's what we're doing here. So basically, I'm setting up a model package group, and here I'm just pulling in the training job that I just ran a while ago, and then using the training job to pull up the model artifact, and then you can see the model artifact, the tar GC file, the model.gc file is out there in S3. And then I create the basic dictionary for creating the model package, providing all the information, and I'm setting it to pending manual approval because it's not yet approved. Somebody has to look at it and then approve it. And then setting up all the inference images to that, and then creating the model package. And that created the model package. And then that hands off to your deployment or ML engineer who will be able to deploy that. In this video, we have discussed 4 layers of governance controls: infrastructure and security layer, data governance layer, AML tools layer, and finally generative AI application layer. We shared a reference architecture and sample implementation for that architecture. And thank you for watching.